So we're going to use the vector component method to find the net force on that wagon. The first step is to draw the two force vectors separately, and then you need to find the x and the y components of them. So as you can see here, I have the two vectors drawn separately, and the green arrows are showing you where the x components are, and the red arrows are showing you where the y components are. So what you need to do is use trigonometry to find the value of those green x components and red y components. So pause the video here for a moment. Think about, should you be using sine or cosine? Do your calculations and then come back and check that your answers are correct. Here you can see my calculations for the x and the y components. You can see that for the x components, I've used the cosine because the x components are the adjacent side of the triangles. For the y components, I've used the sine because the sine is the opposite side of those triangles. The other thing I would like to point out is after I have found the answers for the x and the y components, I've included the direction in the square bracket. So you can see I've written up or down or right beside them. That's important for our next step. So again, pause the video if you need to, check that your answers are correct, and we'll move on to step 2. Step 2, we're going to combine our two x components. So my first vector, if you remember, was 25.4 newtons right. My second x vector was 27 newtons right. So all I'm going to do is add those together to get the total. Then we're going to move on to step 3. And step 3 is doing the exact same thing, except we're doing it for the y components. The only difference here is these y components are in opposite directions. One is up and one is down. So we're not actually going to add them together. We actually have to end up subtracting them. And we're going to get our final answer. Our final answer comes out as positive, which tells me that it's up. If my final answer had come out as negative, I would know it would be down. Then our last step is to put everything together. So I'm going to draw a diagram, which I've done right here, combining my total x and my total y components. Then I'm going to put a dotted line from the start to the finish, which is my net force, and my theta represents the direction or the angle. I'm using Pythagoras' theorem to find the net force, and I'm using the tangent to find the angle. Once I have my answers, I put it all together and I get that my F net is 52.6 newtons east 5 degrees to the north. So again, here might be a good spot to pause the video, take a look at my solution, and make sure you understand the steps.